So 3.9, inverse trig functions.
As with all functions, the inverse of a trigonometric function is the result of switching the input x and output y values of the function. As a result, the output value of an inverse trigonometric function will be an angle measure. We can represent inverse trigonometric functions in two different ways. Sine -1x or arc sine x. With either notation, we would say arc sine of x when reading it aloud.
All right, fantastic. So I want to talk about this a little bit. What's an inverse? It's a what? It's a switch in x and y. And that's still going to hold true on these things. All right. And so when we talk about an inverse trig function, instead of like having like 1/2 or square root 3 over 2 or square root 2 over 2 as our answers, now it's going to be the angle measure. Okay? Because normally we'd input an angle measure and we'd output that number. Does that make sense? And so on an inverse, it's going to be a what? A switch in x and y. And so what's now my input used to be my output, and what's my output is now going to be my input. All right? All right, let's keep going. Oh, before we go on this next part, what's the opposite of multiplying? Dividing. That's my inverse operation, yes? What's the opposite of square rooting something? Squaring something. All right? And so what's the opposite of signing something? No. An arc sine. Okay, that's the inverse operation of signing something. All right, that's the opposite of it. All right, and so what's the opposite of tangenting something? An arctan or an inverse tangent. Okay. All right, so let's look at example 1. Here we go. And so we need to write the statement sine of pi over 6 equals 1/2 in its equivalent form using arc sine. And so all we're going to do, what's the opposite of signing something? Arc signing something. And so now we're just going to arc sine both sides. And so when I arc sine a sine, guess what happens to those? They cancel. And so now I'm left with pi over 6 is equal to the arc sine of 1/2. Now, another way that we can read an inverse sine or an arc sine or so forth is kind of like, at what value is sine 1/2? All right? At what angle is sine 1/2? And so let's think about it. And so let's go backwards. So at what angle is sine 1/2? At pi over 6. There is another one, but we're going to talk about why it's not that other one. What other one is sine 1/2? At 5 pi over 6. And we're going to just explain why we don't actually want 5 pi over 6 as our answer choice in a sec. All right? All right. Keep going, Max. You're doing great.
Because trig functions are periodic, we must restrict their domains to create their corresponding inverse functions.
All right. Fantastic. So let's talk about sine for a sec. Let's talk about sine. First of all, to be a function, everything has to pass the what test? The vertical line test, right? To have an inverse, it has to also pass the what? The horizontal line test, right? And so if we look at this sine function, sine starts at 0 and goes up and then goes down and so forth, right? And then it creates that period, yes? However, once I go past pi over 2, what happens? What does it not pass anymore? The horizontal line test. Does everybody see how this happened? And so once I pass that, it fails that horizontal line test. All right. And so that's why we have this restriction at pi over 2 and at negative pi over 2. Because once I go past this negative pi over 2, it fails the what again? The horizontal line test. All right. And so I want to truly talk about what an inverse is. And so what's my domain normally of my sine function? My domain. It's everything, right? Okay, so my domain normally of a sine function is negative infinity to infinity. Yes? What's my range of my sine function? -1 to 1. All right? And so now if I do an inverse, I flip them. And so graphically, I want to kind of talk about that a little bit. All right? And so I now have a domain from -1 to 1. And now my range is going to be different. And so let's think about this as in my unit circle. And so when is sine -1? So this is going to be my arc sine. When is sine -1? At 3 pi over 2, right? However, I can't call it 3 pi over 2 anymore because it would fail the horizontal line test. Are you following me? And so I actually have to go backwards. So at negative pi over 2, which is the same thing, it's coterminal, all right, it would be right there, all right? And so then when is sine 1? At what? At pi over 2. And so now I end up having this little function that kind of looks like this. And that's what arc sine actually would look like. All right. Now, technically, if it didn't have to pass the vertical line test, it would actually keep going like that. Okay, is everybody following me on this? All right. However, to be a function, it has to pass the vertical line test, which in this case, the normal function has to pass the what? The horizontal line test. All right. And so what I need you to think about here is that it's in between negative pi over 2 and pi over 2 for these answer choices. All right. All right, let's look at cosine now. So cosine, again, has a domain between what? Negative infinity and infinity. It can accept everything, right? Because it's a wave after wave, right? However, to pass the horizontal line test, it fails at certain places. So if I go left of 0, guess what happens? It fails, doesn't it? And then if I go past pi, guess what happens? It also fails. All right. And so on a cosine, or an arc cosine function, it's going to be between 0 and pi. It's going to be between 0 and pi. And so I want to show you what this is going to do. And so now, instead of my range being from -1 to 1, now my domain is going to be from -1 to 1, because an inverse is a what again? A switch in x and y. And so let's think about it. So when is cosine -1? Or when is cosine 1, I should say? When is cosine 1? At what? At theta equals 0. And so arc cosine is actually going to start there. And then when does arc cosine equal -1? When does cosine equal -1? At pi. And so at pi, it's going to be at -1. And so that one is going to actually kind of look like that. Now, why can't it go past pi? Well, because a normal trig function is just going to switch x and y, and it's just going to keep going like that instead. Because it has to be what? It has to pass the vertical line test. All right? So everybody kind of getting this a little bit. Okay. All right, let's keep going, Max. You're doing great.
Similarly, we will restrict our cosine function for the same purposes. However, for y equals cosine, we will restrict our domain to 0 and pi. For the tangent function, we will restrict the domain of y equals tan to negative pi over 2, pi over 2, due to the vertical asymptotes at x equals negative pi over 2 and x equals pi over 2.
All right, cool. So I'm going to talk about tangent first, okay? And so tangent has asymptotes where? At pi's over 2's, right? We just talked about that the other day. And so we have our asymptotes at pi over 2 and at negative pi over 2, right? And what kind of asymptotes are they? They're vertical. Okay, so our tangent function is looking like that, yeah? And so if I switch x and y to make it an inverse tangent function, instead of having vertical tangent lines, guess what I'm going to have? I'm going to have horizontal tangent lines. And so now my horizontal tangent lines are going to be at negative pi over 2 and at pi over 2. All right, and then arctan actually looks kind of like this, okay, because it switched x and y. Now, technically speaking, a tangent function keeps going over and over, right? Yeah. However, if I were to do that with arctan, it would kind of do this, yes? It doesn't do that because it's a function. It would have to pass the what still? The vertical line test. And so, again, arctangent is between negative pi over 2 and pi over 2. Okay? All right, let's kind of put all of that together. All right. So this is the way I think about it. All of this relates back to the unit circle. And if you truly understand the unit circle, these aren't that bad. If you don't understand the unit circle, kind of stinks. All right. So arc sine has to be between negative pi over 2 and pi over 2. And so I think of it as like fourth quadrant and first quadrant. Okay? And you have to think of it that way. Now, it has to be negative pi over 2, and we'll talk about that in a sec. Arc cosine is actually pretty well behaved. It goes from 0 to pi. So arc cosine is between what? The first quadrant and the second quadrant. Arc tangent is the same thing with arc sine. It goes from negative pi over 2 to pi over 2. All right? So let's put it in practice. I'm going to give you a quick nugget, and then we'll kind of explain it. If you have a negative for an arc sine, you're going to get a negative. Arc cosine is always going to be positive. Arc tangent, if it starts negative, it's going to be negative. All right? Those are your little nuggets for right now. All right? And I'll explain why as we go on with these. All right? All right, so let's evaluate some of these. So this first one, we have arc cosine of negative square root 2 over 2. And so the way that we kind of read this is what angle is cosine negative square root 2 over 2? So what quadrants do I have available for arc cosine?
First and second.
The first and second. And cosine deals with what?
X value.
The x value. And so if cosine's negative, what quadrant am I in?
In the second quadrant.
In the second quadrant. So we're right here. And so what angle is that?
3 over 4. Or 3 pi.
3 pi over 4. And so the arc cosine of negative square root 2 over 2 is 3 pi over 4. It's really just going backwards on our unit circle. Let's keep going. So now I have arc sine of negative square root 3 over 2. So now, what is arc sine in between? Okay, I'm going to call it 4 and 1. All right, because we're going this way, truly. And so, which one is this one going to be in? Quadrant 4. And so, what trig value, what angle measure will I get negative square root 3 over 2?
11 pi over 6.
No.
5 pi over 3.
We can call it 5 pi over 3 for now. However, this is wrong. Because 5 pi over 3 is not between negative pi over 2 and pi over 2. Does everybody follow this? Okay, that would not pass the horizontal line test or the vertical line test for that matter. All right, and so what we're going to have to do to this is kind of like subtract 2 pi from it, or kind of just think about it going backwards. All right, and so this would be what?
Negative 2 pi over 3.
No,
No.
just negative pi over 3. All right, so this next one we have is arctangent of square root 3. And so what happened to this one? What is tangent, by the way? Y over x. So how the heck did we get square root 3? What would be my y value? Square root 3 over 2 over 1/2. So sometimes I kind of like to go backwards on my simplifications. I like to unsimplify it. And so when is tangent square root 3 over 2 over 1/2? And so when does that occur? At pi over 3. All right? And so it would actually happen right there. All right? Why can't we actually say 4 pi over 3? Okay, because it wouldn't pass the vertical line test. It has to be between negative pi over 2 and pi over 2. All right?
The angle theta is in standard position. The terminal ray intersects the unit circle at point P, whose coordinates are x, y. The points Q, R, and S are a result of the terminal ray being reflected over the y-axis, the origin, and the x-axis, respectively. For each of the following expressions, determine which labeled point intersects the terminal ray of the given angles.
All right, fantastic. So if we have arc sine, arc cosine, arc tangent, what quadrants are we always in between?
1, 2, and 4.
1, 2, and 4, exactly. So what point can we cross out right away? R. Is any of the answer choices ever going to be R?
Nope.
Never, ever. Okay, make sense? Cool. So arc cosine of x. So when is cosine going to be x? At point what? P.
Oh.
Okay. All right. So on part C, I'm just going to go there for the arc cosine again. So on arc cosine to be negative x, which one's that going to be with? That one's going to be with Q. All right, because I have a negative x on Q. And then part B, it says arc sine is negative y. So which one's that going to align with? S. And then on part D, I have arc tangent being a negative y over x. And so which one's that going to be with? Also S. All right, so on this one, I have arc cosine of negative square root 3 over 2. So when does cosine equal negative square root 3 over 2? What does arc cosine get to be in between? Quadrants what? 1 and 2. It's between 0 and pi. And so which one is it going to be in quadrant what? 2. And so what angle gives me negative square root 3 over 2 for cosine? At 5 pi over 6. So the arc cosine of negative square root 3 over 2 is 5 pi over 6. Pretty good? Cool. Let's do it again. And so now we have arc sine of negative square root 3 over 2. Just kidding. We're going to do arc sine of negative square root 2 over 2. All right. And so what quadrants can I be in for arc sine? 1 and 4, right? Well, which one's this one going to be in? Quadrant 4. And so what angle am I going to get to have sine be negative square root 2 over 2? We can call it 7 pi over 4 for right now. However, that's not going to be my answer. So what is going to be my answer? It's going to be negative pi over 4. All right? Because it has to pass that vertical line test. We have a domain and range restriction on that one. All right, let's do it again. And so now we have arc tangent at negative square root 3. And so on this one, I kind of like to unsimplify it. So how did we get negative square root 3 going on? You got like a negative square root 3 over 2 over 1/2 going on. And so which one did this occur at? What quadrants am I bounded between for arc tangent? 1 and 4. So this one's going to be in quadrant what? 4. And so which one's this one going to be at? It's going to be at negative pi over 3 again. All right. Why can't I call it 5 pi over 3? Because I went too far. All right. It's got to be between negative pi over 2 and pi over 2. Arc cosine of 0. And so what am I bounded between for arc cosine? 1 and 2. 0 to pi, right? And so when is cosine 0? At what? At pi over 2. Exactly. All right. It didn't move left or right, did it? So it's right here. All right. Why can't we call it 3 pi over 2? Because it went too far. All right. All right, this last one. So we have arc tangent of square root 3 over 3. Well, what happened to this? It got rationalized. So I want to kind of unrationalize it. And so when I think about it unrationalized, what would it be? It'd be like 1/2 over square root 3 over 2. Yes? All right. And so on this one, I'm kind of thinking my y's are 1/2, my x's are square root 3 over 2. And so then what would it be at? Quadrant 1, which is at pi over 6. All right. So there we go. So we're going to do one from the worksheet real quick. So this is number 8. So I have 2 arc sine of x is equal to arc cosine of negative 1/2. And eventually I'm going to solve for x. Okay, we can't get there right away. So we're going to have to kind of go in baby steps. And so I can do arc cosine of negative 1/2. Okay. And so what does arc cosine do? Arc cosine is between what? 1 and 2. All right. And then where is cosine going to be negative 1/2 then? In quadrant 2. And so which one is it? What angle is cosine going to be negative 1/2 in quadrant 2? At 2 pi over 3. And so I evaluate arc cosine of negative 1/2 as 2 pi over 3. So now I have 2 arc sine of x is equal to 2 pi over 3. Right? Now I need to start solving for x. But to isolate arc sine of x, I now need to divide by what? 2. And so when I divide by 2, I end up getting arc sine of x is equal to what? Pi over 3. All right. And so now how do I get to x? What is the inverse operation of arc sining something? I sine something. So now I need to sine both sides. So now I'm going to sine both sides. So if I sine an arc sine of x, what do I get? I just get x. And then I have sine of pi over 3. And what is the sine of pi over 3? Square root 3 over 2. And there is my answer on that one.
Wow.
All right.